in is an ordered list of numbers of the form a sub 1, a sub 2, a sub 3, all the way to a sub n. So it's an ordered list, so there is order to that list. There is a pattern to it. A sequence may be generated by a recurrence relation. Remember those? The recurrence relation, where the previous term comes into the calculation. That's where that word recurrence comes from. The previous term reoccurs in the calculation. So a sequence may be generated by a recurrence relation of the form a sub n plus 1 equals f of a sub n. So that's the function, where a sub 1 is given. A sequence may also be defined with an explicit formula, a sub n equals f of n. So in the explicit formula, we do not need the previous term. Notice here, f of a sub n, that's the previous term that's used in this function. This is just n, not the previous term. So we have recurrence relations and explicit formulas. And let me see, do I want to look at this one? We'll look at that one after we do this next example. So this next example is involving sequences. Let's suppose we have a ball that we toss up into the air, and we toss it vertically. I'm going to write it as it moves out horizontal, but that's time. The actual motion of the ball goes straight up and down. Does that make sense? So we toss the ball, it goes up vertically, comes back down. Let's say it goes up here to 20 feet. That's the first bounce. That's the first toss. Hits the ground and it rebounds. Hits the ground and rebounds again. And rebounds again. And it just keeps on doing that indefinitely. Okay? Let's suppose that the ball is tossed 20 feet vertically. Each rebound is 0.8 of the previous height.
It's going to be explicit?
We're going to do both. Yeah. So, h sub zeros, sometimes read h naught, is 20 feet. That is the original toss. H sub 1, the first rebound, is going to be, let me write this the same way I got it in my notes, it's going to be 0.8 times h naught. Okay? 0.8 times h naught, which that would be 0.8 times the 20, which is how much?
16.
16. So the first rebound is 16 feet. H2, the second rebound, will be 0.8 times H1. It's always 0.8 of the previous bounce. So what do we get there? That'd be 0.8 times 16. Zero point eight times 16? 12.8, good. Now, before we write that though, I want to write another deal here. This is like 0.8 squared times h naught, correct? We did 0.8 times h naught here. Now we're doing 0.8 times h1, which h1 is this. So if we do 0.8 times this, we're multiplying two 0.8s, 0.8 squared. You guys all right with that? And tell me what it is again?
12.8.
12.8. I'll put a 0 on there, feet. Good. So h sub 3 will be 0.8 times h sub 2. It's always 0.8 times the previous height. Now, h sub 2 was 0.8 squared h naught. We're multiplying another 0.8 times that, which will give us 0.8 cubed times h naught, which is,
10.2.
good job. Let's do another one. H sub 4 will be 0.8 times h sub 3, so 0.8 times the previous height. This is the recurrence pattern here. This is the explicit pattern, okay? Which you're just multiplying another 0.8 in it, so that becomes 0.8 to the 4th h naught. Now this one we have to round to nearest hundredth. What do you get there?
8.192.
Okay, so I'll just put 8.19 feet, nearest hundredth. Any question about the pattern that's happening here? Okay? So, a recurrence relation would be h sub n plus 1 is equal to what? Look at this first column here.
0.8 times
0.8.
and minus 1.
Okay, but I said h n plus 1, so it's going to be n, right?
Yeah.
Yeah, you had it right. So it's going to be 0.8 times the previous term, which is h sub n. You guys see that? Look how it worked here. Here's h sub 1 is 0.8 times h sub 0, the previous term. H sub 2, 0.8 times h sub 1, the previous term. So h sub n plus 1, 0.8 times h sub n, the previous term. You see it? Any questions there? Okay, so you need more here. The seed is h sub 0 equals 20 feet. And this is for n equals 0, 1, 2, 3, and so on. Okay. So there's our recurrence relation. Next, our explicit formula. For the explicit formula, look at this column. Compare the index here 2, 3, 4 with these exponents. H naught is there. What's our explicit formula look like?
0.829.
Say again?
0.829.
Okay, good. So our explicit formula is going to be H sub n is 0.8 to the n times H naught, which is, what is H naught? What is it? 20. I'm gonna write the 20 in front. 20 times 0.8 to the n power, where n equals 0, 1, 2, 3, So n is the number of bounces, so 0 bounces, hasn't bounced yet. Put in 0.8 to the 0 is 1, the height is 20. That's the initial height that it's tossed to. And you put in 1, 2, 3, and find out the height of each bounce after that. And, you know, we have up here 12.80 feet, and then 10.24, and then 8.19, and so on. Keeps on going. Find for me H sub 10 and H sub 20. Find the height on the 10th bounce and the height on the 20th bounce. What do you get? Yes, sir.
You wrote to the nearest hundred?
Yeah, nearest hundredth is good. So are you using the explicit formula or the recurrence relation? Explicit's the way to go. If you use recurrence relation, you gotta figure them all out. You know, the 4th, 5th, 6th, 7th, 8th, and 9th bounce, you gotta figure all those out before you get to the 10th. And you gotta work them all out up to the 20th, right? Easier to just put in 10, and what happens in the explicit formula when you put in 10? You get 20 times 0.8 to the 10th, which is, to the nearest hundredth, is 2.15. And these are feet. And then when we put in 20, 20 times 0.8 to the 20th, nearest hundredth, what do we get there? 0.23. All right. Is this, good morning. Will this ever equal 0? It'll equal 0 someday? What can we put in for n that'll make that equal 0? Oh, will infinity ever happen? You're not sure? Good, actually, that's a good answer. That's a good answer, actually. So, theoretically, there will be an infinite number of bounces, won't there? Right? No matter what number you put in, you can always put in a bigger one, can't you? Right? So theoretically, there will be an infinite number of bounces. Does that mean the ball will travel an infinite distance?
Yeah.
Overnight versus go straight up to town.
Yeah, because it's go straight.
But will that vertical distance, if you added them all up, will that be infinite?
Very close to it.
Will it bounce for an infinite amount of time?
Yeah. So you want theoretically.
Okay. These are the questions that we're going to be answering. when we study